Coming second to Eric Dollard is very difficult, I assure you, because he can go on like this for probably about 5 hours, and we'll have you convinced at the end of the 5th hour. But I'd like to demonstrate something for you people that are not familiar with a longitudinal wave. I'm going to let Eric hold one in. Let's start off with the transverse wave. Now, as we hold this hose here,
sideways flow.
You can see that it takes a finite time for this transverse wave to propagate from one end of this hose to the other. You can see there's a finite time. That finite time is the speed of light. And that is what we're considering our limit in the electromagnetic world in classical theory. Okay, now Eric and I are going to demonstrate the longitudinal wave, the one that travels infinitely faster than the speed of light and has no losses. just jerk it like I said. As you can see, if you move one end, the other end moves instantaneously. There is no time delay as there is with the transverse wave. And it's very important to pay attention to that because that's the one we completely ignore. That is the pressure wave essentially through the ether, as it was. One way to describe it. But you should remember that little demonstration because we spend all our time looking at just one of two waves. The transverse wave is unfortunately the one with the losses. The longitudinal wave is the one with no losses that we don't even acknowledge exists. And that's also the one, I might add, how our minds transmit between each other. And that's the one that cells use to communicate with each other. It's the one that nerves use to communicate with each other. I have a more interesting chart. I'll use Eric's chart here. As you can see, if you were to stack these cells up here side by side of number 2 here, this is the transmission line with the capacitors in series and the coils in shunt. If you put another one here and another one and another one, what you find is you have 4 capacitors in a little cell-like structure. You have 4 capacitors, a coil shunt, 4 capacitors, a coil shunt, 4 capacitors, a coil shunt. It's my theory that the capacitors are the cell membrane of the cells next to each other, and the coil is probably DNA, would be my guess. And it is a guess, of course, but I've done I have a feeling that's how the nerve fibers work, and also probably how life itself develops energy from the ether and scalar fields. Of course, the concept of the ether was banned, when was it, Eric? About 19...
Einstein.
Yeah, Einstein, yeah, basically. Einstein knew how it all worked, but he did not, was not allowed, shall we say, to divulge it. All right, I have a little lecture on 2 devices that I've found quite interesting, seeing as how nobody really understands how these things work. Everybody thinks they know how a transformer works. We're going to go over that one. And we're also going to go over this interesting device here, which I've been passing around for the last 15 minutes, ball bearing motor. Now you can win a lot of bar bets with this one, and a lot of people would lose it, hands down. But all we do here is we take 2 ball bearings of any kinds you want, connect them in this kind of fashion with an ammeter, connect to the outer race of each ball bearing, use a conductive shaft of some kind, makes no difference. I use brass, you can use steel, you can use anything you want, and get a 4 to 6 volt battery and just connect them to this thing, and you'd never think it would run, but it does. Eric, I'm going to need to get this started. You have to give it a...
0 starting torque.
You have to give it a spin. Stand out of the way of the thing. You have to give it a spin because its starting torque is very low. But its running torque is very high. Very interesting device. It'll run both directions, one polarity. So you can win a few bar bets with that one, boy, let me tell you. And if anybody wants, I've tried it with about 5 different types of bearings. They all work just fine, and it doesn't seem to be fussy. You've got to get at least 10 to about 50 amps going through the bearings before it works properly. But Eric and I both thrashed this one around for quite a while, and I agree with Eric. It proves that we've got 2 vortexes operating here in the current somehow through the ball bearings, and the vortexes themselves are making the balls rotate. And that's another theory in itself, because the energy does vortex in and vortex out in the ether. All right, now we'll get into something a little more interesting. Does everybody know what a transformer is? They're on every power pole in every city, in every residential area, every industrial building. I work out of UCSB, and I deal with them every day. We've got probably about 400 of them out there, large ones. And they seldom cause any trouble, and but unfortunately, nobody really quite understands how they work. And you say, oh, I know how a transformer works. I learned it in electronics class and all that, and that's true, you did. But we're going to go through a little basic principles of electronics here and power generation, right, just for a second. If I take a magnet, bar magnet right here, and a piece of steel, and hold the steel up next to the bar magnet, what happens is, in classical thinking, the magnetic flux lines of the magnetic field are attracted to this piece of iron. The iron tries to close the field lines, and you get a concentration of field lines in the iron itself. Iron is like a sponge. It just kind of grabs all the flux lines up. And the other principle we learn in electronics is that if we take a bar magnet and cause it to move around a conductor with a meter on it, the moving magnetic lines of force cutting the wire field generates a current that you can read with a meter. And everybody has demonstrated that at some time or another, I'm sure. That's not anything. But the principle is the field lines cut the wires, and the wires somehow generate electricity. An interesting theory. On the primary winding of a transformer, this is a toroid. This is hopefully a perfect transformer. It has no core losses, and we'll just assume it has very good high permeability core. If you put an AC signal generator on this thing and your typical primary winding, the primary side we understand quite well, because when the current flows through the winding, the flux lines, it tries to make a bar magnet basically out of this piece of core right here, because you have turns around it and you have a piece of steel in it. So what happens is all the flux lines, just like this piece of iron up here, jump from the winding into the core itself, the magnetic core, and it forms a magnetic loop, actually a magnetic flux path around the transformer. And since it's AC in here, the flux, the magnetic field is changing, both direction and magnitude, with the alternating source. Is everybody following me so far? And nobody's disagreeing with anything? Okay, that's...
No way.
Are you?
No way.
You're not following? Well, you don't have to follow. That's all right.
The snake oil.
All right. Yeah, snake oil. You can explain this when I get through. Anyway, the problem exists in the secondary coil, which we all assume when the magnetic flux lines supposedly cross the winding of the secondary coil, it generates current, producing current in this arbitrary resistive load. The problem is that iron sucks up most all of the magnetic field, like 98%